Hey everyone, this is Roto Motion and Douglas GB introducing Season 1, Episode 8. We're continuing with our advanced line of training here. If you remember, Episode 7 was going through trace setup. This episode will focus on trace acquisition. And then our last episode of Season 1, which will be time trace, which is the result of all of the things you need to do to test your vector generator and find out what may be wrong with it. So before we go into trace acquisition, this is Rotomotion. I will be guiding you through this, and Douglas will be asking questions along the way as if you were sitting in front of me as a student. So here we go. Trace setup. Just make sure your board has this in order. Just as a reminder, make sure your clock BNC is on R4 pin 9. If it's a space dual, of course, this is what we have in front of us right now. So ours is on R4 pin 9. We also have our probe clicked to the halt test point. That is the start. So in repeat of that, the start BNC needs to be clipped onto halt. And then we have our data probe connected to the data BNC, and make sure it is on 1x. That's a common mistake. Some of these probes have different magnifications, so make sure it is on 1x. And then the last, make sure that you have watchdog disabled. That's super important, especially for trace acquisition. Okay, we are going to assume that you have done all the prerequisites from our last episode, and we're off to the trace acquisition tab. Now, in the trace acquisition tab, we're going to accomplish something that's very similar to Fred has done a marvelous job of making it very automated by having a voice speak back to you, and the dings that you might be used to in signature analysis as we walk through the board doing a trace acquisition of the vector generator section, so that we can later see these time traces and analyze what might be wrong. We're going to guide you through a couple of these trace acquisition test points here in a minute. But before we do that, let's just kind of go through these different buttons. So speak, that would be if you want the computer to speak back to you, to guide you through the next pin. Ding tells you if your acquisition is the same as reference. Reference meaning a good signal, a reference point from a good signal that might have been taken from a previous board or from a load from the library. As you can see here, we have loaded from our library the halt test, and it already has references in it. You want to clear a trace, you would press the clear trace button. Or if you wanted to do a full reset and start from scratch, you would press reset. Copy to reference. This would be if you're making your own reference file, which you're welcome to do and upload to the library so that we can all share it. And then, of course, before you copy the reference, you might want to clear the reference or start over. The clear reference button provides that option for you. The reference match light is quite nice. If you're not paying attention to the voices or the ding, it is a indication that your signal that you took an acquisition from is a match from what the reference was before. Okay, if there's no questions, we're going to start doing a trace acquisition.
Yeah, I don't think there are any questions because most of this stuff is gonna, when you load the test, it's gonna already be in there. Like you said, all the reference signals that you need to know what's good that you're comparing to. uh, how many cycles the thing goes through during the test. That's all. That all comes with the test that you loaded, right?
Exactly.
Yeah. So you're just so yeah. At this stage, we're just gonna see if our board how it does. Right.
All right, so here we go. This is exciting, guys. This again, the speaking part makes it very automated, and also the ding, if you remember, is a indication that the signal trace that you're acquiring is a match to the reference. So we're going to start with uh, N4 pin 1. Go ahead, Douglas.
So I click start to.
N4 pin 1.
So that starts the process, but it hasn't acquired anything yet, right? It's just kind of telling me, hey, here we go. Put your probe on that pin.
Yeah, so now you'll place your probe on N4 pin 1.
Okay, it's on there, and then I click that button again to actually do it.
Correct.
N4 pin 2.
So what happened there? The ding.
The ding gave you a indication that that N4 pin 1, the board you're using, is an exact match to the reference file. So you can trust that N4 pin 1, that particular signal that you took, is a good signal.
Okay, all right, and now I'm on N4 pin 2, and I click that again, right?
You click on acquire.
N4 pin 3.
Another good one.
N4 pin 4.
All right, now I'm cruising.
N4 pin 7.
Ooh.
N4 pin 6.
As you can see, it's quite nice. This little wizard just guides you through the acquisition process.
N4 pin 9.
Yeah, because I'm across the room from my
N4 pin 10.
across the room from the laptop that's running this. I just have the mouse, so I can push the button.
N4 pin 11.
Over on the bench where I'm doing the actual probing. So I'm looking and listening across the room. So
N4 pin 12.
the speech and the ding really help.
N4 pin 15. Test complete.
Ta-da! Very, very, very nice. Kudos to the flow process that Fred built into this. Okay, so we're done, and we will cover the time trace tab, which now has data in it based upon the acquisition that we just did. There is one other part that we wanted to cover before we end this episode, and I'll let Douglas take it over. It's in the trace setup. It was about acquiring specific signals that are combined into one signal. Go ahead, Douglas.
Oh yeah, thanks. Yeah, so these are the signals that we just gathered. Signals to trace. OP210. Those are on the schematic. OP2 was N4 pin 1. OP1 was N4 pin 2. It sounds familiar, right? Yeah, that's because here they are by name, and in the acquisition they are by location, although it also gives you the signal name. So it's it all matches, which is nice. And that is going to be board specific. We're doing space dual, so the INI file told the tester what locations correspond to which signal. But yeah, so we gathered 3 different signals, OP2, 1, and 0. And when we go to display them, we could display them individually like these other ones down here, and actually they are here, OP2, 1, and 0. But those those lines tell us something, but it might be more helpful in this case because they're opcodes to display them as the instruction that they represent. So that's what Fred has built into this is you can group these together. That's what these brackets do. It means OP2, 1, and 0. So group those 3 bits all together and then interpret the 3 bits as the opcode. Uh, the state lines 3, 2, 1, and 0. Those 4 bits get grouped together and then they're displayed as a hex value. And that's here. That's this 098F. That's the actual state of the state machine. Again, you can also display them individually. So, this kind of gives you a high level view of what's going on when things are going right. And then if they go wrong, then it's helpful to have the more detailed individual view on a signal by signal basis that we have down here later in the list. So very flexible, both for being able to be concise, but also being able to really drill down and see in detail what you want to see.
Thank you, Douglas. Thanks for re-explaining that. That was really clear. Like mentioned before, we will get into time trace tab on the next episode. So until then, please practice trace setup and trace acquisition. Time trace will make you think. Time trace is a good way to see all the data, but we will make you think in the next episode. So until then, take care, guys. We'll see you later.